here. Голік Ярослав. Yaroslav, where are you?
Yes, I'm here.
Please. Where? Let's start. Так, только нет вашей презентации. Ярослав.
Сейчас я ее включаю.
Да.
Есть сейчас, да?
Да.
Хорошо.
Так, все видят? Хорошо. Давайте, Ярослав.
Dear Commission members, let me introduce you my work about fatty acid and pigment composition of plant materials and chloroform extracts of green and fermented rooibos. The plant I am going to talk about is called Aspalathus linearis. It is a shrub which belongs to the legumes family. It is an endemic plant in the Soderberg mountain range in the Western Cape province of South Africa. The plant is usually called rooibos, as well as the beverage, which is made from its needle-like leaves. It is because of the beverage this plant became so popular around the world, and in most countries it is commonly consumed as an ordinary tea, although indigenous South Africans use it for medicinal purposes. And today the annual production of plants' raw material exceeds 12,000 tons. There are two kinds of rooibos, both in beverages and plant materials, the green one and the red one. The latter is also often called fermented. In fact, they are different kinds of the same plant and different the fermentation degree. Green rooibos is fermented similarly to the green tea, therefore it is more expensive, and the red one is fully fermented. There are also many grades of rooibos. They differ in the ratio of leaves to the parts of branches and the degree of grinding of raw materials. The highest quality material is considered to be with the high prevalence of leaves over the branches. To date, the chemical composition has been extensively studied. The plant contains a lot of vitamin C in the fresh form, very little of tannins, derivatives of benzoic and hydroxycinnamic acids, and does not contain caffeine. But the main group of compounds is flavonoids, which rooibos is very rich in. Approximately 20 of them have been identified, but the most important of these are the dihydrochalcone C-glycosides aspalathin and northofagin. The former was found only in this plant. And the biological activity of rooibos is primarily related to the flavonoids and hydroxycinnamic acids contained in this plant. Main effects of aspalathin and northofagin are hypoglycemic effect, antioxidant effect, and antimutagenic effect, which were confirmed in many animal studies. So, of our work is the qualitative and quantitative determination of lipophilic substances, mainly fatty acids, and pigments, chlorophylls A, B, and carotenoids, in the chloroform extracts and dried plant materials of green and fermented rooibos by different instrumental methods. And this work may be considered relevant because the data on the composition of lipophilic substances and pigments in the rooibos have not yet been published. In addition, this research will allow to understand the biochemical matter of the fermentation process in this particular plant and to determine the most suitable plant type for medical use. And here we start our researches. As the research materials, we took dried leaves of green and fermented rooibos, a rather low quality of the Osmanthus TM. Chloroform extracts were obtained by total extraction in a Soxhlet extractor with further concentration by direct distillation, followed by vacuum distillation and drying in the desiccator. The study of the lipophilic substances content was carried out using gas chromatography with mass spectrometric detection. The study was conducted using the green and fermented rooibos materials, as well as chloroform extracts obtained from them. And the content of lipophilic pigments was studied by spectrophotometric and HPLC methods, also using both materials and extracts. So here we have a result of our extraction. And upon chloroform extraction of green and fermented rooibos materials, oily to the touch, resinous, thick extracts were obtained, which looked more like a dry extract, which were dark green, almost black colored. And the yield were 0.91% for green rooibos and 0.83% for fermented one. Here we have results of our research on the lipophilic substances composition. We obtained 4 gas chromatograms, and here you can see the chromatogram of the fermented rooibos material, where 48 substances were identified. And here you can see the chromatogram of its chloroform extract, where 54 substances were identified. In the sample of green rooibos material, 21 substances were detected, and in its chloroform extract, 52 substances were detected. And almost all of the detected substances in these samples were identified, but for this work, we selected them based on the quality index. And the quality index indicates how accurately the tested substance was compared with the corresponding substance in the library. And usually substances with a quality index of 90% and greater are considered to be correctly identified. However, some researchers consider the substances with a quality index of 50% and more. However, despite all of this, there are some cases in which substances with a quality index of more than 90% are identified incorrectly. And we have chosen substances with a quality index of more than 50% for this research. And as you can see, from all 4 samples, 12 saturated, 6 unsaturated, and 5 dicarboxylic fatty acids were identified, which you can see on the slide. And also, some phytosterols were identified in the green rooibos chloroform extract. Here you can see the diagram of fatty acids in fermented rooibos material. Those fatty acids that prevailed in the sample from each group are circled, and ratios of groups shown. And as you can see of the saturated fatty acids, 14-methylpentadecanoic acid prevailed. Of the unsaturated, 9,12,15-octadecatreenoic acid prevailed, and from the dicarboxylic acids, docosahexaenoic acid prevailed. From the sample of chloroform extract of fermented rooibos, the same acids prevailed, which are 14-methylpentadecanoic and 9,12,15-octadecatreenoic acid. However, in this sample were absent all dicarboxylic acids. In the green rooibos material, as you can see from saturated acids, docosahexaenoic acid prevailed, and from unsaturated, 9,12-octadecadenoic acid prevailed, and from the dicarboxylic acids, docosahexaenoic acid prevailed. In the sample of green rooibos chloroform extract, from the saturated acids prevailed hexadecanoic acid, from the unsaturated 9,12,15-octadecatreenoic acid, and from the dicarboxylic acids docosahexaenoic acid. Here we have results of our research, this time on the pigment composition. We obtained the common for all sample spectra, which you can see on the slide. It was spectra during the spectrophotometric analysis, and you can see that all samples showed some results in the form of peaks, based on which quantitative content of pigment was calculated. Here you can see the results as shown in this diagram, where fermented rooibos samples are shown on the left and green rooibos samples are shown on the right. However, we also conducted HPLC analysis to confirm obtained here results, but this time qualitatively. And here you can see the results of HPLC analysis. This is the fermented rooibos material sample. You can see on this chromatogram by the arrows indicating straight line instead of the characteristic peaks. Chlorophylls A and B were absent in the fermented rooibos material sample, as well as in its chloroform extract sample. Here you can see the green rooibos sample, and here is present the characteristic peak for chlorophyll A, as indicated by green arrow. And in its chloroform extract, you can see the both characteristic peaks for both chlorophyll A and B. Based on both spectrophotometric and HPLC analysis, the new diagram was built, and you can see that chlorophylls A and B, which are indicated in red and orange colors, are absent in the fermented rooibos materials. So, quantitative results obtained from spectrophotometric analysis were not confirmed qualitatively for these samples. And this can be due to the presence of degradation products of chlorophyll and in the samples, which also gave some results in the spectrophotometric analysis. And the quantitative results indicated that chlorophyll A in the content of green rooibos is found to be 3 times greater than a chlorophyll B, and the carotenoid content in the green rooibos is found to be by 3.59 times more compared to the fermented one. So here are the conclusions of our work, which are: the extract yield of fermented rooibos was 0.83%, and for the green rooibos 0.91%. Prevailed fatty acids in the fermented rooibos were 14-methylpentadecanoic acid, 9,12,15-octadecatrienoic, and docosahexaenoic acid. The same acids were prevailed in its chloroform extract, however, except for the absence of the docosahexaenoic acid. In the green rooibos material prevailed docosahexaenoic, 9,12-octadecadienoic, and docosahexaenoic acids. And in its chloroform extract, hexadecanoic, 9,12,15-octadecatrienoic, and docosahexaenoic acids prevailed. We also found in the green rooibos phytosterols such as camphosterol, sigmasterol, and 22,23 dihydrostigmasterol. Concerning the pigments, chlorophylls A and B were absent in the fermented rooibos, but carotenoids were present. In the green rooibos, both chlorophyll A and B were present, and chlorophyll A appears to be 3 times more than chlorophyll B, and carotenoids in 3.59 times more than in the fermented rooibos. Based on this, we can make some conclusions about the effect of fermentation on the chemical composition of lipophilic substances and pigments. So during the fermentation, the yield of lipophilic fraction decreases, isomerization of hexadecanoic acid to the 14-methylpentadecanoic acid occurs, increases the amount of polyunsaturated fatty acids, the composition of chlorophylls A and B occurs, and decreases the amount of carotenoids. We also can conclude that during the extraction process, the composition of dicarboxylic acids occurs. And what about the most suitable rooibos type for the medical use? As you can see, in the case of rooibos, it is hard to say unequivocally what type of plant material is more suitable for medical use. Therefore, the choice will depend on the substances needed and the extract yield. If the bigger yield of extract needed, or the higher content of chlorophylls and carotenoids, or the presence of phytosterols needed, then the material of choice will be the green rooibos. And if the higher lipid content is required, especially with a high content of polyunsaturated fatty acids, then a fermented type of rooibos should be selected. And we believe that the results of our work can be further used in research with the aim of maximizing the use of raw materials and biologically active substances contained in it during creation of new medicines. And I thank you very much for your attention.
Thank you, Yaroslav. Does anyone have any question?
Yes, I have.
Valentina Nikolaevna, please.
I have one question. Do you know any medicines from Aspergillus cinealis? In other countries, I know that Ukraine have not.
Thank you for your question. As far as I know, there are no officially produced medicines from the rooibos, but there are many. It is used in the, Africa and other, mainly in Africa, by the indigenous people and as a health beverage. And components from it, such as asparagine and notofagin, are now used in many different researches. As far as I know, even in clinical researchers, and but no drugs in the classical meaning of this term.
Thank you.
Yaroslav, please see a chat. There are 3 questions from Alexander Sirachuk to you.
Okay.
В конце в самом, even 2 people ask you.
Okay, so the question is, does your fermented rooibos was prepared from green rooibos used in your study? If not, how can you conclude about fermentation effect? Thank you for your first question, and I can tell that our fermented rooibos was not prepared for green rooibos. We took materials separately, so we took fermented material and we took green material. They are fermented differently. It's not the point to do the green rooibos and then ferment it to the red one. So they are different degree fermentations, and when we bought them for the research, it was separate materials. And the second question was, fatty acids are not volatile and can be analyzed by GC method. What sample preparation did you use to make them fly in GC system? I think I don't. They are not volatile, but the method was the next. When we conducted this result, there was very high temperature, and this temperature made them evaporate. So during the process of hydrolysis of lipids and methylation of fatty acids, there further were used with a temperature, and the temperature makes them fly in the GS system. And the third question was, how did you identify your compounds by GSMS, and what level of confidence that you identified it properly? What library? Thank you again for your question. And we identified our compound based on the NIST mass spectra library. And level of confidence, we used those substances with a quality index of 50% and more. Usually for fatty acids, which I presented here in my work, they were almost 90% and more, mainly fatty acids. Other substances were lower, but I didn't show them in this work.
Alexander Andreevich, are you satisfied? Okay. For the next, please, there are 4.
I have.
Yes.
Елена Владимировна, пожалуйста.
I have. Where the mass spectrometry study was carried out?
Thank you for your question. The mass spectra study was carried out on the Department of Natural Products Chemistry in the Kharkiv National Pharmaceutical University.
Thank you. And the second, what do you know? What type of pharmacological activity is associated with fatty acids? Fatty acids.
With fatty acids, okay, thank you. And it's some kind of difficult question because the fatty acid, there are a lot of fatty acids, and depending on the study, they have different biological activity. For example, the eicosapentaenoic and docosahexaenoic acids, they constitute partially the vitamin F, and they can also lower blood cholesterol level. For example, undecylenic acid has antifungal properties, and other example can be the nervonic acid, which can prevent Alzheimer's disease. And arachidonic acid is the precursor for eicosanoids, and so it depends on the particular fatty acid. So they have.
Thank you. I'm satisfied.
Thank you.
Так, and there are 3 questions in the chat.
Okay. So the question is, did you analyze kind of rooibos? What we make?
Наталья Александровна, выключите микрофон.
Я хотела задать вопрос.
Сейчас, давай. Давай через один чат, а потом я вас позову. Хорошо?
Ага.
Так,
Also,
Ярослав.
да, did you analyze kind
Да,
of
да, да. Давайте этот. Мгм.
Отвечать, да?
Мгм.
Yes, we analyze the kind of rooibos that we make drink from. We can make drink from the both in fermented rooibos and green rooibos. And what medical properties it has? It has antioxidant, antimutagenic, and hypoglycemic actions. And thank you for the question.
Наталья Александровна. Давайте сейчас Наталья Александровна.
Thank you very much. I have a question. Tell me, please, where on those HPLE chromatograms you showed us, we can see that carotenoids were also identified in samples.
Okay, thank you for your question. I want to show it on my presentation here.
Тогда надо включить презентацию.
Here, for example, the
Сейчас включится.
For example,
да.
the fermented rooibos chloroform extract spectra, you can see the first part of the chromatogram from 0 to approximately 8 minutes. It will be the xanthophyll group of carotenoids, and from the 35-minute to 40 minutes approximately, it will be the carotenes. And it's the same for all samples. Here will be the xanthophylls, and here will be the carotenes.
Thank you very much.